There's an excavator operating in a quarry in Montana right now that has logged 47,000 hours. That's over 5 years of continuous runtime. It's never had a major breakdown, never been down for more than a day. The maintenance schedule? Oil changes, greasing, and filter replacements. That's it. The year? 9. The brand? You'll have to keep watching to find out. Meanwhile, a contractor in Texas just traded in his 2022 excavator after 3 years because the repair bills were eating him alive. Hydraulic failures, electronic problems, emission system failures. The machine spent more time in the shop than on the job. That's the difference between excavators built in the 1980s and machines built today. Back then, reliability wasn't a marketing bullet point or an optional upgrade package. It was the baseline. It was the foundation. It was what separated manufacturers who survived from those who disappeared. These 10 excavators represent an era when breaking down simply wasn't acceptable, and the engineers who built them made damn sure it wouldn't happen. Number 10. Liebherr R974. Let's kick things off with German engineering at its finest. The Liebherr R974 hydraulic excavator from the 1980s wasn't the largest or most powerful machine on the market, but it established Liebherr's reputation for building excavators that simply refused to quit. Weighing around 85,000 pounds with approximately 260 horsepower, this machine was designed for serious production work in quarries, mines, and heavy construction. What set the R974 apart was Liebherr's obsessive focus on component quality and system integration. German engineering culture in the 1980s demanded that every part, no matter how small, meet exacting standards. Bearings were overspecified. Hydraulic components used generous safety factors. Steel fabrications were thicker and more robust than competitors deemed necessary. This wasn't just good engineering, it was a philosophy that viewed failure as unacceptable. The hydraulic system on the R974 exemplified this approach. Liebherr didn't use off-the-shelf components from third-party suppliers. They designed and manufactured their own hydraulic pumps, valves, and cylinders to their own specifications. This vertical integration meant every component was engineered to work together seamlessly. Pump output was perfectly matched to system requirements. Valve timing was optimized for smooth, precise control. Cylinder seals were designed for the specific pressures and temperatures they would encounter. Operators who ran R974s remember them for their smooth, predictable operation. The hydraulic controls provided exceptional precision, allowing operators to work with finesse despite the machine's size. Digging forces were strong and consistent. Swing speed remained steady regardless of load. Boom and stick movements were coordinated and responsive. This control precision wasn't achieved through electronic systems or computer management. It came from mechanical excellence and hydraulic engineering brilliance. The R974's undercarriage demonstrated Liebherr's commitment to longevity. Track frames were fabricated from high-grade steel with generous wall thickness. Track links were heat-treated and precisely machined. Rollers and idlers used sealed bearings that required minimal maintenance while delivering exceptional service life. Contractors routinely got 8,000 to 10,000 hours from undercarriage components that competitors replaced at half those intervals. Number 9. John Deere 690D. John Deere's entry into the large excavator market produced the 690D, a machine that brought agricultural equipment reliability to construction applications. Weighing approximately 90,000 pounds with around 250 horsepower, the 690D competed directly with established manufacturers while offering something they struggled to match: that legendary Deere reliability that farmers had trusted for generations. The 690D featured a John Deere diesel engine that embodied the company's engineering philosophy. Deere had built their reputation on engines that started reliably, ran smoothly, and operated for thousands of hours without major issues. The power plant in the 690D was designed with conservative power ratings, generous bearing clearances, and robust internal components. Deere engineers knew that farmers and contractors needed equipment that worked, not equipment that impressed with peak horsepower numbers that couldn't be sustained. What made the 690D particularly reliable was John Deere's systems engineering approach. They didn't just bolt components together and hope everything worked. They engineered the entire machine as an integrated system, where every component supported overall reliability. The cooling system was oversized to ensure the engine never overheated, even under sustained maximum load. The hydraulic oil coolers were generously specified to maintain optimal fluid temperatures. Filtration systems used high-quality filters with excellent dirt-holding capacity. The 6090D's hydraulic system used Vickers components, industry-leading pumps and valves known for reliability and longevity. But John Deere didn't just install Vickers parts. They worked with Vickers to optimize component specifications for excavator applications. Pump displacement was carefully matched to engine power. System pressure was set to deliver strong digging forces while maintaining component longevity. Relief valves were precisely calibrated to protect cylinders and motors from pressure spikes. Contractors who owned 690Ds discovered they required surprisingly little maintenance beyond routine service. The machines didn't develop the chronic problems that plague lesser excavators. Hydraulic leaks were rare because John Deere used quality hoses, fittings, and seals. Electrical problems were uncommon because the wiring harnesses were properly routed and protected. Structural cracks didn't appear because the boom, stick, and frame were appropriately engineered for the loads they would encounter. Number 8. Poclain 1000 CK. The Poclain 1000 CK represents French engineering excellence applied to excavator design. Poclain was a pioneer in hydraulic excavator development, and the 1000 CK from the 1980s showed their deep understanding of what made excavators reliable. Weighing around 110,000 pounds with approximately 300 horsepower, this machine was built for heavy-duty applications where failure simply couldn't be tolerated. What set Poclain apart was their hydraulic systems expertise. They weren't just excavator manufacturers, they were hydraulic systems specialists who built excavators. This distinction was crucial. Poclain understood hydraulics at a fundamental level that many competitors couldn't match. They knew how to design pumps that delivered consistent flow across all operating conditions. They understood valve timing and how it affected control precision. They recognized that hydraulic oil temperature management was critical for system longevity. The 1000 CK's hydraulic system was a masterpiece of 1980s engineering. Poclain designed their own pumps specifically for excavator applications, optimizing them for the cyclical loading patterns excavators experience. The pumps maintained consistent output despite rapidly changing loads, ensuring smooth operation and reducing stress on downstream components. Control valves were precisely manufactured with tight tolerances, providing excellent sealing and minimal internal leakage even after thousands of hours of operation. Operators loved the 1000 CK for its exceptional control characteristics. The machine responded precisely to control inputs with no lag or hesitation. Digging felt smooth and powerful. Swinging was controlled and predictable. Combined movements were coordinated and natural. This operational excellence came from hydraulic system design that prioritized performance and reliability over cost reduction. The 1000 CK's structural design reflected French engineering pragmatism. The boom and stick were fabricated from high-quality steel with appropriate section modulus to resist bending under load. Stress concentrations were minimized through thoughtful design and proper welding procedures. Pin joints used quality bearings and bushings that could handle both radial and thrust loads. Everything was engineered to last, not just to meet minimum requirements. Number 7. Caterpillar 235. The Caterpillar 235 hydraulic excavator from the 1980s represented Caterpillar's commitment to building machines that worked, period. Weighing approximately 120,000 pounds with around 325 horsepower, the 235 was a large production excavator designed for mining, heavy construction, and other demanding applications where reliability directly impacted profitability. Caterpillar's approach to reliability started with component selection and integration. They didn't use the cheapest parts or cut corners to reduce manufacturing costs. The 235 featured Caterpillar's own diesel engine, a power plant designed for continuous duty in the harshest environments. The engine was conservatively rated, meaning it produced its specified horsepower with minimal stress on internal components. This approach sacrificed peak power numbers for long-term durability, a trade-off that operators appreciated when their machines kept running while competitors' equipment sat broken. The hydraulic system on the 235 used Caterpillar-designed components integrated with carefully selected third-party pumps and valves. Caterpillar engineers understood that hydraulic reliability started with clean oil, proper cooling, and appropriate system pressures. The 235's filtration system was exceptional, using high-efficiency filters to remove contaminants before they could damage pumps and valves. The hydraulic oil cooler was generously sized to maintain optimal fluid temperature even during continuous heavy work. What made the 235 particularly reliable was Caterpillar's testing and validation process. Before releasing the machine for production, Caterpillar subjected prototypes to brutal testing regimes. They operated machines continuously under maximum load. They deliberately abused components to identify weak points. They tested in extreme temperatures, dusty conditions, and abrasive materials. Any component that showed premature wear or failure during testing was redesigned until it met Caterpillar's standards. The 235's undercarriage exemplified Caterpillar's expertise in tracked vehicle design. Caterpillar had been building tracked equipment since the 1920s, and by the 1980s, they had refined undercarriage engineering to near perfection. Track frames absorbed shock loads without transmitting excessive stress to the upper structure. Track links were precisely manufactured and heat-treated for maximum wear resistance. Rollers and idlers featured sealed lubrication systems that protected bearings from contamination. Number 6. Hitachi EX400. Hitachi's EX400 excavator from the 1980s demonstrated Japanese engineering's focus on reliability through precision manufacturing and quality control. Weighing approximately 90,000 pounds with around 270 horsepower, the EX400 competed in the large excavator market by offering exceptional reliability that translated directly to lower operating costs. What distinguished Hitachi excavators was their manufacturing quality. Japanese industrial culture in the 1980s emphasized continuous improvement and defect elimination. Every component in the EX400 was manufactured to tight tolerances using quality materials. Hydraulic cylinder bores were precisely honed for minimal leakage. Pivot pins were ground to exact dimensions for proper fit and bearing life. Fabricated steel components received appropriate heat treatment and stress relief. The EX400's hydraulic system reflected Hitachi's systems engineering approach. They designed pumps, valves, and cylinders to work together as an integrated system rather than assembling components from various suppliers and hoping they'd function properly. Pump output was precisely matched to circuit requirements. Valve timing was optimized for smooth control and efficient operation. Cylinder seal designs were specific to the pressures and speeds each cylinder would experience. Operators appreciated the EX400's smooth, refined operation. Japanese excavators in the 1980s earned reputations for being pleasant to operate, and the EX400 exemplified this characteristic. Controls were light and precise. Machine movements were coordinated and predictable. The cab was relatively quiet and vibration-free. This operational refinement wasn't just about comfort. It reflected the attention to detail that made the machine reliable. The EX400's electrical system showed Hitachi's electronics expertise. Hitachi was a major electronics manufacturer, and they applied that knowledge to excavator design. Wiring harnesses were properly engineered with appropriate wire gauges and quality connectors. Components were sealed against moisture and contamination. The electrical system was logically laid out for easy troubleshooting. These details prevented the electrical problems that plagued many competitors' machines. Number 5. Komatsu PC400. The Komatsu PC400 from the 1980s represented the culmination of Komatsu's excavator development expertise. Weighing approximately 92,000 pounds with around 280 horsepower, the PC400 competed directly with Caterpillar and other established manufacturers by offering comparable capability with exceptional reliability that won over skeptical contractors. Komatsu's approach to reliability emphasized proven designs and conservative engineering. They didn't chase technological innovation or cutting-edge features. Instead, they focused on perfecting fundamental excavator systems. The PC400's diesel engine was a Komatsu design that prioritized longevity over peak power. Internal components were robust. Bearing clearances were appropriate for long service intervals. The cooling system was generously sized. The PC400's hydraulic system exemplified Komatsu's expertise in this critical area. Komatsu manufactured their own hydraulic pumps, valves, and motors, allowing them to optimize each component for excavator applications. Pumps were designed for the cyclical loading patterns excavators experience. Valves featured precise spool tolerances for excellent control characteristics. Cylinders used quality seals and smooth-bore finishes for minimal leakage and long life. What made the PC400 particularly reliable was Komatsu's focus on field serviceability. They understood that contractors needed to perform maintenance and repairs quickly without specialized tools or extensive training. Filters were accessible, oil sampling points were convenient, major components could be removed and replaced with standard equipment. This serviceability meant problems that occurred could be addressed quickly, minimizing downtime. Number 4. Case 1288. Case's 1288 excavator from the 1980s represented American engineering focused on practical reliability. Weighing approximately 95,000 pounds with around 265 horsepower, the 1288 was designed for contractors who needed dependable equipment that wouldn't break their budgets on maintenance and repairs. Case understood that many contractors operated with limited technical support and needed equipment they could maintain themselves. The 1288 reflected this understanding through straightforward design and accessible components. The engine was a proven design that mechanics could troubleshoot using conventional diagnostic techniques. The hydraulic system used industry-standard components that were available from multiple suppliers. Everything about the machine prioritized maintainability. What made the 1288 reliable was Case's focus on robust construction rather than sophisticated technology. The boom and stick were heavily built using thick steel and generous section modulus. Pivot points used quality bushings and pins that could handle side loads and shock without failing. The upper structure frame was fabricated from heavy plate steel with appropriate reinforcement at stress points. The 12T88's hydraulic system was straightforward and dependable. Case used quality pumps from reputable suppliers, matched them with appropriate control valves, and designed the circuit for reliability rather than maximum performance. System pressure was set to provide good digging forces while maintaining component longevity. The hydraulic oil cooler was properly sized to maintain optimal operating temperatures. Operators appreciated the 12T88's honest, straightforward operation. The machine didn't try to be something it wasn't. It was a working tool designed to dig, lift, and load reliably day after day. Controls were direct and predictable. Performance was consistent and repeatable. The excavator did what you asked it to do without drama or surprises. Number 3. Demag H85. The Demag H85 hydraulic excavator represented German engineering excellence applied to large excavator design. Weighing approximately 185,000 pounds with around 450 horsepower, this massive machine was built for mining and heavy construction applications where reliability was absolutely critical because downtime meant thousands of dollars in lost production. Demag's approach to reliability started with over-engineering every component. German engineering culture viewed adequate as insufficient. The H85's structural components were massively built using high-quality steel. The boom was a massive fabrication that could handle digging forces with minimal deflection. The stick was equally robust. The upper structure frame was essentially a steel fortress designed to last for decades of abuse. The hydraulic system on the H85 showed Demag's unwillingness to compromise on quality. They used their own hydraulic components designed specifically for large excavators operating in demanding conditions. Pumps were massive units that delivered huge hydraulic flow for fast cycle times. Control valves were precisely manufactured units that provided excellent control despite their size. Cylinders were robust assemblies with generous safety factors. What made the H85 particularly reliable was Demag's attention to cooling and filtration. Large excavators generate tremendous heat in their hydraulic systems, and managing that heat is critical for reliability. The H85 featured an extensive hydraulic oil cooling system with multiple heat exchangers. Filtration was equally comprehensive, using multiple filter stages to ensure hydraulic oil remained clean despite operating in dusty, dirty environments. Operators who ran H85s in mining operations reported exceptional uptime despite brutal working conditions. The machines operated in extreme temperatures, abrasive materials, and continuous heavy loading. Yet they kept working shift after shift with minimal unplanned downtime. Scheduled maintenance was straightforward. Component life was excellent. The excavators simply did their jobs without drama. The H85 proved that reliability at scale was possible when manufacturers refused to compromise on engineering and quality. These machines cost more initially than competitors' offerings, but contractors who calculated lifetime operating costs discovered the H85 was actually the economical choice because it spent so much more time working and so much less time broken. Number 2. O&K RH40. Orenstein and Koppel's RH40 excavator was a mining shovel that redefined reliability expectations for ultra-large excavators. Weighing over 400,000 pounds with approximately 1,100 horsepower, the RH40 was designed for the most demanding mining applications where any breakdown cost tens of thousands of dollars per hour in lost production. The RH40's diesel-electric drive system represented O&K's innovative approach to reliability. Rather than using conventional hydraulic systems for propulsion, the RH40 used diesel engines driving generators that powered electric motors at the tracks. This configuration provided several reliability advantages. Electric motors could deliver massive torque without the complexity of hydraulic transmissions. The system required less maintenance than hydraulic drives. Component life was excellent. What made the RH40's hydraulic system exceptional was O&K's focus on quality and redundancy. The excavator featured multiple hydraulic circuits, each dedicated to specific functions. Crowd and hoist circuits were independent, allowing the machine to continue working even if one circuit experienced problems. Pumps were industrial-grade units designed for continuous duty. Valves were massive, precisely manufactured units that could handle huge flow rates. The RH40's structural design was simply phenomenal. The boom was a massive lattice structure that provided incredible strength with relatively low weight. The dipper stick was equally impressive, a huge fabrication designed to handle the extreme loads of large-scale mining. The upper structure frame was essentially a steel building, fabricated from heavy plate with extensive internal bracing and reinforcement. Number 1. Caterpillar 245. At the top of our list sits the Caterpillar 245, the ultimate expression of 1980s excavator reliability. Weighing approximately 140,000 pounds with around 375 horsepower. The 245 was Caterpillar's large production excavator designed for mining, quarrying, and heavy construction applications where reliability wasn't negotiable. What made the 245 the most reliable excavator of the 1980s was Caterpillar's complete commitment to engineering excellence. Every system was designed, tested, and validated to ensure it would deliver consistent performance for thousands of hours. The diesel engine was a Caterpillar design that had proven itself in countless applications. The hydraulic system used Cat's own pumps and valves optimized for excavator duty cycles. The undercarriage drew on decades of tracked vehicle expertise. The 245's hydraulic system exemplified peak 1980s engineering. Caterpillar designed every component to work together seamlessly. Pumps delivered precise flow rates matched to circuit requirements. Control valves provided smooth, progressive control over machine functions. Cylinders were manufactured to exacting tolerances with quality seals and precision-honed bores. The entire system was engineered for minimal internal leakage and maximum efficiency. What truly set the 245 apart was Caterpillar's field testing and validation process. Before releasing the machine for production, CAT subjected prototypes to brutal testing regimes that simulated years of operation in compressed timeframes. They identified and corrected weaknesses before customers ever experienced them. Components that didn't meet Caterpillar's standards were redesigned, not decontented. The 245 structural engineering showed Caterpillar's deep understanding of excavator stress analysis. Boom and stick sections were designed using finite element analysis to optimize material distribution. High-stress areas received appropriate reinforcement. Welds were executed to high standards with proper procedures and inspection. The result was structures that could handle the severe cyclical loading excavators experience without developing cracks or failures. Caterpillar's commitment to parts availability and service support made the 245 particularly reliable in practice. CAT maintained extensive parts inventories worldwide. They provided comprehensive service documentation and training. They stood behind their products with warranty support and technical assistance. This ecosystem meant 245 owners could keep their machines running efficiently even in remote locations.